Hello and welcome to day 23 of the first trimester of Honors Precalculus. You do have a test coming up. It's not going to be a quest, it'll be a test, but it is coming up in about 5 class periods. So let's warm up a little bit and go back to Ferris wheels, which are just so much fun. I know you love them. So here's what's going on. You have a 300-foot Ferris wheel. So let's just draw this circle here, 300 feet. So that means it's going to have a diameter of 300. And at one revolution every 15 minutes. And it's got a 10-foot high boarding platform. So there's a boarding platform 10 feet high. It's 10 feet high right there. At time 0, you're at the 12 o'clock position. So at time 0, you're at the 12 o'clock position, which is all the way up there. And how high off the ground will it be after 3 minutes? So how much of a revolution are you going to make in 3 minutes? You're going to make 3 over 15 of one revolution. So how many degrees is that? So that's out of 360 degrees. So that's 72 degrees. Now, it doesn't say it, but it really wants to keep on going counterclockwise. So you're going to be going this way. And in that 3 minutes, you will have gone 72 degrees. So you've gone 72 degrees. Now, when we do sine and cosine, you have to add in this part. That's the 90 degrees. So really, it's 90 plus 72 degrees here for this point right here. And we're asking how high off the ground are we? So we're going to get this value right here, this value all the way to the platform. That coordinate right there is going to be our sine of theta. And in this case, the radius is 150. So y is going to be 150 sine of 162 degrees because we need this entire angle right there, entire angle. So when you use your calculator for that, which you really do, you're going to end up with about 46.353 feet. And that's to the platform right there. Sorry, that's to the midline. I'm sorry, what's to the platform? That is to the midline. That's to the midline right here because this, when you're doing this, that's 0, 0 right there. So that 46 is, this 46 is going to be right here. So what do we end up with total height? Well, you're going to be 150 feet all the way to here, but then it's going to be another 10 feet to right there. So to add in 150 and 10 to the 46.353, you end up with 206.353 feet. So find the point on the circle of radius 12 that corresponds with each of the following. Round your answers to 3 decimal places. Well, this is just using the same formula that we just used. We have r cosine theta, comma r sine theta, and then you just have to be careful of the units. So this is degrees, and this is radians right here. So you have to use 2 different modes on your calculator. This is just going to be 12 cosine of 220 degrees and 12 sine of 220 degrees. And you use your calculator, you end up with negative 9.193 and negative 7.713. 3 decimal places. If it doesn't specify, please use 3. So then you have to translate into, not translate, but you have to turn your calculator into Radian mode. And this is just going to be 12 cosine of 5, comma 12 sine of 5. I know it's annoying not to have pi in there, but you don't have to have pi in there. And this, when you use your calculator, is this 404. Negative 11.507. We know multiples of 30 and 45, but not things like 220. Okay, so let's graph sine. What does this look like when we graph it? Well, sine is opposite over hypotenuse. So when you hear the opposite side is 0 and the hypotenuse is 1, it's just going to be on the x-axis. So at time 0, you're right there. Now, when you're at 90 degrees, so when you're at pi over 2, you're going to be all the way back up here. And in this case, when you're here, the triangle turns into be, 1 over 1. The hypotenuse is always 1, but now you end up with the opposite side, which is going to be the height in this case. So you're going to be all the way up here. And therefore, so that's time equals pi over 2. And then when you go all the way around, you're back down at 0 again. And remember, sine is just the y value, So the y value here is 0, then the y value is 1, and then the y value is 0. And then it's going to go down, so it's going to go negative down below, and then it's going to come back up again. And then in between, you're going to end up with It's going to look like this. Up, down, up. And I missed my curve there, so I'm going to try it again. Do it nice and smooth. It's one of the advantages to these surfaces. We go up, and then that shape right there just gets repeated over and over again. It's a periodic function, so one thing you can do really nicely, I like doing this, I draw it once nicely, and then I paste, and then I just move it right there, and then I'll do it again right here. I'm going to paste it again. I'm going to move it right here. So draw it once nice, and then you can draw it real nice in repetition. It's periodic, it repeats, there you go. So when you're graphing the sine function, what's the period going to be? Well, it repeats itself every 2 pi. The amplitude, it goes all the way up to 1. That's the distance from the midline, in this case the x-axis, to the highest or lowest points. And then the third point is, what's the midline going to be? Well, that's just the x-axis, y equals 0. So let's do cosine. It's the x values. What's the x value here? Well, that's going to start at 1, and then at pi, it's going to go back to 1. Pi is going to go, pi, it's going to be all the way over here, and that would be, the x value there is -1. So it's down here, and then it goes back up again. So what does this look like? Well, you end up with, you graph all these nice points here. You get my whining dog in the background. Sadako says hi. Goes down, goes up, goes down. And remember, if you just do one nice curve here, if you do one nice curve, one nice one like this, you can then copy it and paste it. So that's what I'm going to do here. Hold the side of your stylus, take it like this, you copy, right click and paste, and then you can just put it right there. And then you can do the same thing right here once again. There it is, just like that. Okay, it's pretty cool. So in this case, the period is still 2 pi, the amplitude is still 1, and the midline is y equals 0. Same thing. Now, the only difference here when you're graphing 3 sine theta is this 3, and all that's going to do is triple the amplitude. It's going to triple the amplitude. So sine will still start here, and it'll come back to 0 at pi and 2 pi and 3 pi, but it's going to go all the way up to 3 and then come back down, and then go down to 3 right here, and then go up again. So you can just keep on doing this, go down again, and back up, and then it'll do the same thing going back. So all that 3 does is it stretches it vertically by a factor of 3. What does this 2 do to cosine? That just moves the whole graph up by 2. So instead of starting at 1, which is where cosine starts normally, it would start at 3, and everything just shifts. So it's going to go like this. So went down too far there. It's going to go to here, and then to here, and then up like this. And it's not straight lines, remember, because it's cosine, so it's going to end up looking like this. Connect the dots nice with a curve, and then it goes back like this. So that 2 just means up 2. So here we have a shift and a reflection. So this is sine. Sine normally, sine of 0 is 0. It would start here. What's going to happen instead is it's going to go pi over 2 left. So it's going to be the same shape, pi over 2 to the left. So it's going to start here, but then instead of going up, it's going to go down because of this -2 and be stretched by a factor of 2. So if it went up, it would normally just go up like this, but now it's going to go down and go down to 2. It's going to go down to 2 here. So that means it's going to go back up, and the same curve repeats itself over and over again. So it's going to go up like this, and then down to here, and then up, and then down. Same thing. Now, all of this relies on knowing what sine and cosine look like. Those are your base graphs. So just like we started the year with transformations of graphs, we now have 2 base graphs, sine and cosine. So what happens here, this is going to go, mean the whole thing's going to go down 1. This is going to go right pi, and then vert stretch by 3. So when you do this, what you want to do is move it pi to the left. I'm going to go pi to the right, and then down 1. So cosine usually starts here, but if you stretched it by a factor of 3, it would be up here. Now we're going to go pi to the right and down 1. So it went up because of that 3, got stretched 3, and then it went right pi, but then it goes down 1. So this time it's actually going to start right here. Now, it's going to have that midline at -1 right here because of this going down 1. So what that means is it's the same, we haven't changed the period on here, so it's just going to be here, and then it's going to be the same thing reflected there, and then up again, and then up above again to here. And I went not far enough down. It goes down, sorry, it's got to go down all the way to 4 here. It's got to be the same distance from the midline. So then it goes to here, then it goes to there, goes to there, goes back up again, goes back up again, it goes back up. So once you do one rotation, you have the whole thing. But just to recap, cosine would normally start at 1. This graph stretches it by 3, so it goes up to 3, but then it goes right by pi, which is there, right by pi, and then it goes down 1 because of that -1. That's why we started there instead of at 0, 1. This just takes practice. Make some up, test it out on Desmos, and see how you do when you do it by hand.